Okay, so now test it. Are you getting audio? Okay. The y cap equal to predict of x comma theta. So what are the coefficients we got through gradient? With that matured coefficients, we are doing prediction. So before training, what is our coefficient value, sir? We kept all values zeros. Okay. So now after training, the latest coefficients will be into theta. With that theta, the prediction is done. So we have 6 rows as inputs. That's why 6 predictions you got. Y cap. What is our target variable as per our data? A is weight, height are inputs. Cholesterol is target. But our actual cholesterol is in 60, 70, 65 like that. But here values are different because these are the scaled predictions. Now our intention is just to test the accuracy. That's why doing one more function, define accuracy. Actual labels and predicted labels we are given. Y and Y cap. These two are the arguments. This is a regression problem. In regression problem, accuracy is based on the whether prediction is good or bad. How can you say based on the closeness expectation? Let's say the closeness expectation. If closeness expectation is like 90, then how much distance? 10. 100 minus 10. That means the distance expectation. 100 minus closeness. What is the distance formula? Y minus Y cap divided by Y. So here value can be positive or negative. That's why taking absolute value. This ABS is just a general Python basic function which works on single value one. But here our Y and Y cap are numpy arrays, right? That's why np dot abs of y minus y cap by y into 100. This is what a distance between actual and predicted. Think that, sir, our actual cholesterol 25, predicted cholesterol 26. 25 minus 26, absolute, how much? Absolute, 1. Divided by y, y is 25. 1 by 25 into 100, 4. That means there is a 4% distance between 25 and 26. Like this, there are 6 rows, 6 distances you will get. But my closeness expectation 90, 100 minus 90, which is 10. If distance is less than or equal to 10, my prediction is good. Okay. Distance of. Here I am giving condition. Distance less than or equals to distance expectation. Distance expectation. Suppose out of 6 predictions, 5 predictions are less than 10. 5 distances are less than 10. It picks only those 5 elements. How many? Dot size. Think that I am giving it as PCNT. That means number of predictions successful, pass count. And total number of elements I want. N is equal to y dot size. Suppose total 6, sir. Pass count is 5, sir. What is the percentage? 5 by 6 into 100. That means pass count divided by n into 100. This is what accuracy we are returning that one. Now I am going to test it. Accuracy of y. Capital Y is your actual values, actual cholesterol values. Of course, scaled cholesterol values. Comma, your predictions are in Y gap. I am expecting 90% closeness. Test it. 33% accuracy. Why we got very less accuracy means we have only 6 rows. Within the 6 rows, very less number of patterns. So general model is what whenever you want to try, there should be, in order to provide more patterns, more data should be there. Understand? Okay, this is 90% based. Let's go with 80. Let's for just only for testing. On 80% closeness base, I got 66. Let's make it 70 closeness. Still same. Still same. Okay. Think that accuracy is expected. Expected accuracy achieved. Actually, I am expecting 90. Think that 90 H or more than 90 H. Then new data will be given. For the new data, the predictions have to be applied. Okay. Suppose new data is like this. I am keeping that new data into another file. Same ID, name, age, weight, and height. But I don't know their cholesterols. Already we build a model. With that model, we need to do predictions about this cholesterol. Suppose these are the new patients. The new patients data is like this. First person. One more person I'm taking. Last. Okay. Let's say the data new pats. What are the data you have seen? This is scaled or unscaled? Unscaled. But our model is based on what? Scaled. So before applying prediction, first you should transform into scaled. Okay. First I'm reading this data. In file is equal to open of the file path. First line is header, just removing that. Remaining data lines. Now we have 3 elements into this data. Data is a list. List has 3 elements. Separate the required entities. Age, weight, and height. For D in data, I'm splitting them into words. Comma is delimiter in our data between fields. Appending all ages, weights, heights into those empty lists. What is the position, sir? Age position 3, 4, 5. That means 2, 3, 4 are the indexes. Two for age. Three for weight. And minus one, which is last one for height. After loop, all these entities are ready. Understand? Do you remember in yesterday program for original data already we separated age and standard deviation. Mean of age, mean of standard deviation of age. Mean of weight, standard deviation of weight. By using those things, we need to scale. Now, A is equal to np dot array of A. As a numpy array, we are converting. W, same thing I am doing for W. Okay. Now you can scale it. I'm using capital A for this. In capital A, I'm keeping scaled data. All these ages are what? Unscaled ages. Understand? What is the scaling technique, sir? Second scaling technique is what? Second scaling technique, sir. Each value minus mean divided by standard deviation. Understand the point, sir? Apply that scaling here. Got it? Scale of A. Or else already we did one more matrix, right? Scale matrix, right? Entire if I pass matrix, if I pass a matrix, except first column, remaining all columns will be scaled. For that we did one function, scale matrix. Let's say predictable matrix P equals to np dot c underscore of. Tell me. First column ones. np dot ones. Len of A or data. Let's keep data. Data has three elements. np dot ones of 3 means 3 ones will be produced. That is as first column. Second column age, weight, and height. So this data is what? What is the size of P now? 3 rows, 4 columns, 3 by 4 matrix. Just check it. One bracket mystery here. New paths.txt. is a 3 by 4 matrix. Now I'm going to scale it. Scale matrix of P. As per our yesterday code, what this function is doing, except first column, remaining all columns will be scaled out. Now check latest P. These are scale content. Now I'm going to apply prediction. Let's say y cap is equal to predict of input matrix or coefficient matrix. The matured coefficients are in theta. You got like this. Print y cap. These are predictions. Understand? These predictions are what, sir? These predictions are what? Scaled predictions. But we did a wrong. Our original data has how many rows? 6 rows. The new patient's data, 3 rows. If you directly apply scale, what it is doing? This scaling is based on what? Mean of these 3 rows, standard deviation of these 3 elements. Understand the point, sir? By which coefficients, by which mean and standard deviation you have scaled your original trained data. By using same data, by using same mean, same standard deviation, you have to scale these things. Understand the point, sir? That's why instead of using that scale matrix, here I am using capital A is equal to A minus MA. What is that MA? Yesterday we separated some variables. Check this part. MA is what? Mean of age. SA, standard deviation of age. Like this MW, SW, MH, SH. Already we separated these things. So this has to be scaled based on that one. Understand? So I am writing that divided by SA. Capital W for weight. Do same thing. W minus MW divided by SW. Capital H minus MH divided by SH. With this, prepare your matrix. Understand the point? Capital P notation I am giving for predictable matrix. NP dot C underscore. First I need ones. Let's say Y equal to NP dot ones of data. O as first column, capital A second, W next, H next. Now my prediction. Let's say YC, Y cap. Predict of input matrix P, coefficient matrix theta. Print P, print YC. Now you check. NP dot ones len of data, sir. Data is a list, right? For np dot ones, we need number. Here you just observe. Len of data I am given. Len of data means 3 elements, right? So for these scaled inputs, the output will also be, the predictions will also be scaled predictions. Just I think you cannot see on this projector. Only output I will copy, just check it, sir. On the notepad I will copy. These are outputs. How are outputs, sir? Scaled or unscaled? Your model is built based on scaled data. That's why predictions will also be scaled on. We should unscale them. So what is the formula we have used for scaling? For y? Y minus mean of y you have taken, divided by standard deviation of y you have taken. Understand? I want this y, sir. Now think that the value is this one. The value is 0.65 for one row. How to unscale it? Multiply with standard deviation and plus mean value. Understand? To get this original y, think that this 0.65 is the result of this expression, sir. To get y, what to do? Standard deviation, that has to be multiplied with standard deviation and plus with mean. Correct? Apply now the same thing. Yc equal to Yc plus. Yc is already scaled values. That means in the place of 0.65, they think that Yc. 3 predictions are there. Yc into standard deviation. Standard deviation of original labels. What is that variable in our data? I forget that variable name here. It's the name we kept. MCSC we said. Mean of cholesterol, standard deviation of cholesterol. Standard deviation of cholesterol plus mean of cholesterol. Understand? This is what your predictions. Let's say predictions is equal to. Just run it. Now check latest value of predictions. Print predictions. For the first person, 61 is the cholesterol. Second person, 63. Third one, 67 is the cholesterol. Understand? So final predictions will be scaled predictions. So scaled predictions your end user cannot understand. Your customer or end users cannot understand. That's why again you need to, the scaled one you have to unscale it. So the same formula we reversed it. The prediction into standard deviation plus mean. To scale, what is the formula? Your actual minus mean divided by standard deviation. Now you are reversing. Understand the points? So why we scaled this data, sir? Point number 1. Already I told you one point. A model which is going to use derivative, which is going to apply derivative. Okay. The derivative is always expecting scaled content only. Understand the point? If you don't scale it, error will be keep increasing. If you scale and then train, for every iteration error will be decreasing. Not only this one, sir. Go with any other model which is going to use this derivative. You have to scale it. Remember. Based on this, if the question is where scaling is not required. Generally, at the time of working with a decision tree, random forest with such kind of naive base, with such kind of models, I don't apply any scale. I don't apply any scaling technique. Why? Because those models are not using derivative. Understand? Suppose in logistic, in gradient style, again a derivative. SVM. SVM two ways, with a derivative, without derivative. In SVM algorithm also there is a optimizer, sir. Margin ascent optimizer. That algorithm is called margin ascent algorithm. Again, margin ascent will apply derivative. So that you have to scale your data. Understand the point, sir? Where to use scaling, where not to use scaling. Okay. Okay, sir. Tomorrow, about all these 25 sessions, prepare. And tomorrow I am going to test you with an examination. Tomorrow you will have two examinations. A morning, so this time machine learning exam, and next time immediately Python session. Got it? So I shared you all these. I think yesterday video I did not share you. The first till 22nd videos I shared with you. 23, 24, 25 pending. So these three I will complete today. I will give you. And Python already I shared 11 sessions or 10 sessions. So with those things, just to prepare and come tomorrow. Attendance is mandatory tomorrow. If you skip, next onwards I will skip. Okay. Be careful and prepare well. This examination is not to blame you. Already I told you. Just to understand you better, how well you are following. Got it? The online team, thank you very much.